Okay, I'm going to certainly sound like a broken record. I hope it sinks in over time. And this is important for all your classes, that what you do is you certainly attend the lectures. I'm going to say as you move forward through your education, it's just not attending lectures, but it's also reading a textbook before you attend the lectures to try to get more familiar with the topics. All right, and that's going to be something that's going to be really, really important as you move forward educationally. All right, to read a textbook before attending lectures. Of course, the way we structure the courses, we basically, I'm going to say, you know, partially doing that for you, reading to you. But here's the deal. We want you to listen to what we present to you. And what we're presenting today is we're basically presenting what's known as a loci. I'm going to say it's a set of points that we can describe. All right. Now, certainly there's, a lot of loci problems, but we're going to be describing a set of points. And we're going to be talking about what's called a conic section. And a conic section is a section of a cone, which you should be familiar with it. And certainly, visually, I would think that, a section of a cone, the most obvious one would be a circle. And I can certainly describe the set of the points for a circle. It's the set of all points that are equidistant from a center. Now, there's another conic section that you studied in Math 100. It's called a parabola. So in this section of the notes, we're going to be discussing, the description of the loci, that's the set of points, and for two conic sections, for the circle and for the parabola. All right. So once we go through that, we'll certainly do examples. And then what you're going to do after that, you're going to study what we presented to you, including the examples, and then you can do supplemental activities. So I'm going to go to the whiteboard a little while, but I'm going to just point out what we're doing over here. And, we'll talk about a circle first. We provide good pictures for you. And the reason for that is we want you to look at good pictures, not some, crappy picture at a blackboard where some teacher really can't draw a circle, myself included. And we're not looking for perfect, we're looking for concepts. So my understanding here, concept here for circles are really simple concept. What is it going to be? You get a center point, and then you got a bunch of points. How many? An infinite number of points that are equidistant from the center. That's the description for a circle. All right, we'll go through that example. We'll go through the derivation of, excuse me, of the formula as well. All right. So, granted, you might say, oh, gee, I did that in Math 100. I don't need to be walked through that. And maybe you don't. Maybe you can start saying, I can do that on my own. Now, next up, you also did parabolas. We'll review what you did in Math 100 for parabolas. Now, for Math 100 parabolas, what you did is, you certainly did the x-intercepts if they were easy. If they weren't, you didn't do it. You did the y-intercept. Well, I'll be honest with you, Math 100, that was always easy. You did the vertex. Well, in Math 100, they gave you a formula and they derived the formula for you. We also derived the formula in Math 119. All right, we've done that. All right. Now, what else did you do in Math 100? You did this axis symmetry. But here's the deal. What we're going to be doing is we're going to be explaining what is that set of points, and we're going to talk through that. All right. Now, when I say we talk through that, first we review the 100 material and the 119 material, and then what do? We start talking about how this point set is described, and then we're going to try to derive a formula that's based on that description, just like we did for circle. All right. And granted, it might be tough. We do give you good pictures. When I say we give you good pictures, they're accurately drawn. That's what I mean by good pictures. Much better than anyone can do by hand. All right. Then we're going to go through examples. All right. So I'm going to switch to the whiteboard. Give me one moment to do so. And again, I want to point out what we're doing over here. We're in this section over here. And again, you have access to the notes. Make sure you know that. And again, if you're certainly in my class, I'm going to follow my notes. If you're in another class and another teacher's doing this, that's fine too. And my videos are published, and that may or may not be helpful for you. All right. So let's just talk about circles first off. And as I'm doing that, I just want to kind of look at it. All right. So someone says, "Oh, this is an equation of a circle." Yeah, I see it. Definitely, clear as day. So if I were looking at that picture and someone said, "What's the center?" Let me write this down for you. I think I can do it. And by the way, I'm ballparking it. So what's the center of that circle? Well, looking at it, to me, it looks like 1 minus 1. This is the one thing I'll tell you about circles that, or any picture for that matter, that may not be 1 minus 1, but I'm thinking to myself is, if it's not, I'd have a really tough reading that graph then. right? But I'm gonna assume it looks like, 1, that's the x coordinate, and the y coordinate looks like -1. It could be wrong though. Maybe it's not. All right. Now I'm looking at this point over here, and I'm starting to think that maybe I could write that point down too. All right, I'm just looking at the picture, by the way. Very primitive. What's this point over here? Well, I'm going to say it looks like 1, 1 to me. And what's this point over here? Well, looking at it, and again, I'm looking at it, it looks like 1 minus 3. And this is what you did mathematically, you did what's called the four-point technique. What's this point over here? And what you did was you went up and down, left and right. Again, I'm looking at a picture that looks like the point 3, comma, minus 1. And what's this point over here look like? Well, I'm going to look at it and say it looks like -1, -1, right? So I got my 4 points on the circle. Again, I want to emphasize these points are on the circle. I clearly see those points on the circle. Now, what else do I see? I see this line segment. And I'm going to claim that line segment is the radius, and a radius has a length. Now, by the way, I guess I could draw a triangle for that, but I don't think it would be a good idea. What I'm going to look at, if this is a circle, every single radius would be the same. So if I drew this radius over here, or this radius over here, or this radius over here, or this radius over here, they'd all be the same. Now, someone says, could you draw another radius? There's an infinite number of them. What I want to discuss is what's the length of the radius. And probably the easiest way for me to do that is to look at the center and realize to get to any point in the circle, I have to move over. Now, someone says, how much do you move over? Well, I'm kind of looking at my scale, and it looks like I'm moving over 2. I'll write that down for you. Well, I want to look at the other ones and see if they're all 2. 2, 2, 2. Not bad. All right, not bad. So what do we have over there? We looked at the picture, very primitive. We saw that we had a circle drawn. We looked at the center of it. And again, I want to point out where the center is again. It's right over here. The center is not on the circle though. We examined the radius. It appeared to be 2. And we looked at 4 key points. And that's going to be our technique. Have we seen circles before? Many, many times. What I want to do is I want to go back to what you did in Math 100 and talk about this. All right. So I'm going to pull this on the side. I want to talk about what you did in Math 100, and then we'll look at our picture again. All right. Pull this on the side. So in Math 100, what did you do? Well, your teachers told you that, this is an equation of a circle. They would say, even in the sentence, they'd say, find the center and radius of the circle. Well, you might say, let me see if I can do that. Well, what did the teachers recommend you do? Put the x's together, and we'll talk about what the equation looks like later. Put the y's together. I'm just reviewing what you did in Math 100. Add the constant both sides 2. Now, by the way, when the teachers told you what the equation of a circle was, we'll get to that later, but the bottom line is you probably have some local memory of what you've done in Math 100. Right? Now, what did you do now? You took half of this, which is -1, and you squared it, and you would get 1. And then what you did was you added 1 to both sides of the equation. So someone says, why would you have done that? We're steering towards a real simple form. It has something to do with the distance formula. All right, what do you do over here? Half of 2, which is 1. You square it, you would get +1 now. And you add 1 to both sides. Now, what would you get there? You get a perfect square. Another perfect square. And on the right side, whether it's a perfect square or not, doesn't matter to me. It is a perfect square though. What is it? 2 + 1 + 1 is going to be 4. And what's 4? It's 2 squared. We're popping up with a lot of perfect squares. So why don't you simply discuss a circle with you? I'll draw a picture over here. We'll talk about the derivation of the formula. There's a center here. All right, there's a point along the circle. We'll call it XY. And there's a radius between those 2 points. And what do I know about the radius? If it's a circle, if this is a circle, all points along the circle, every single point along the circle would be exactly r units from the center. And what's a center? Well, typically the center, I'll write this down for you, is a constant point. It's not changing. It's not moving around. And we call it h, comma, k. So all we do is we use the distance formula. Let's write this down for you. So what's the distance going to be? The distance between the point, the center, and this point over here, well, it's pretty easy to write down. What's the distance? It's r. What's the distance formula say? Let's write this down. And again, r is the radius. It's going to be x minus h squared plus y minus k squared. And there's nothing wrong with writing that way, but tradition has it, we square both sides. Before I do that, I want to point out, if this is a circle, r must be a positive number. So what do you get up here? R squared is equal to x minus h squared plus y minus k squared. This is an equation of a circle. Push this over here. This is what you did in Math 100, and that's how your teachers explained to you Math 100. This is the equation of a circle, certainly in standard form, by the way, with center h, comma, k, and radius r. All right, let's go back to the example we were doing. And oh, gee, this looks just like it. So I think I could write a couple of things down now. I could certainly write the radius down. And what's the radius 2? And I could certainly write the center down. What's the center going to be? Let me point this out to you. Now, if you look at this thing over here, it's going to be 1. Some people remember this by saying this would have to be 0 for that to be a center. And that's true. All right, so 1. Write that down for you. Comma. I'm going to look over here. And what would this be? Well, if you look back at the form, it's going to be y minus a minus 1. So it's going to be minus 1. Or think of this one as a big 0 at minus 1. Then what did your teachers do? They said, draw the circle. I'll do that. Not a very good circle, right? Put the center down and then talk about the 4 characteristic points along the circle. This is a pretty bad looking circle. I know that. Well, what's the center? Well, I'll write this down for you. The center, is 1 minus 1. Then the question is, what's this point over here? Well, what we're going to suggest to you is move up 2 units. And if you moved up 2 units from that circle, right? If you moved up 2 units from that center, what would you be at? 1. X didn't change, right? What do you get for y? 1. So if you're at minus 1, you move up 2. I'm sorry, if you're at minus 1, you move up 2, you'd be at 1. Let's move down now. Again, the x didn't change, but the y did, right? So if you're at minus 1 and you move down 2, you would be at minus 3. Let's do these things, and that's moving left to right. Now, what's not changing there is the y. But if you're at 1 and you move right 2, you'd be at 3. All right, now I'm going to move left. The y didn't change. But what happened to the x? I moved left 2 units. That would be minus 1. Now, what I want to do is I want to just go back and I want to see, how we did with that and see if we got it right. And someone says, what do you mean, see if you got it right? I'm looking at the better picture and I'm saying I have the center down, right? I have the radius down. And do I have those 4 key points down? And I do. 1 minus 3, 1, 1, 3 minus 1. I got to scroll over a little tiny bit. And minus 1, minus 1. Not bad. We did it right. Okay. Let me go to the next page. And also the next page is me going through the work on that particular problem. All right. So let me talk about the next example. And when I'm doing the next example, I want to point out what the next example is. It's this guy over here. So I'm going to just simply pull that to the side. And I'm going to walk you through it. So again, in Math 100, they would have said, oh, find the center and radius of the equation of the circle. All right, well, what's a circle? I'll write this down for you. So it's going to be x squared. Whoops, sorry, let me get the white. X squared plus y squared plus 10x minus 6y plus 25. And we're just reviewing what you did in Math 100. Get the x's together. I always like to leave a little space over there. The y's together. And get the constant on the other side. That's minus 25. I did that. Then what are you going to do? Complete the square. How do you do that? Again, when f size over here, half of the 10, which is 5, square it. What do you get? Plus 25. And again, I'm adding 25 to both sides of the equation. Now, what am I going to do over here? Well, I'm going to take half of minus 6, which is minus 3, and square it. And what do you get? Plus 9. And let me write that down for you. Well, let's write down what we get. We get a bunch of perfect squares. And what do we get? X plus 5 squared plus y minus 3 squared. And if you add that together, you get 9, or 3 squared. All right. So what's the center? It's fairly easy to read it. The center is going to be minus 5. Again, that's where this thing becomes 0. And what does this become 0? At 3. What's the radius? The radius is r, and it's equal to 3. Now, my goal over here is, graph a circle out. All right, I'm just going to graph it out. And someone says, oh, your circles look terrible. They really do. Center. And then I got a bunch of points, but I'm not going to put a bunch of points down. I kind of ballparked it. I want to put those points down. All right. So let me write this down for you. The center, minus 5, 3. I want to move up. I want to move down. I want to move right, and I want to move left. And we'll check this with the key later. Now, if I move up and down, the x is not changing. If I move left and right, the y's are not changing. Now, if I move up, what's changing? The y. So if you're at 3 and you move up 3, well, that's simple. That's 6. If you're at 3 and you move down 3, you'd be at 0. And we'll check this later. All right, let's keep going. If you're at minus 5 and you move to the right 3, you're at minus 2. All right, we'll check this later, don't worry. If you're at minus 5 and you move left 3, you'd be at minus 8. All right, let's look over. And we'll see how we did. And what I'm looking for, I got my picture. They don't have a picture, but I'm looking for the points. And let's go through this one at a time. Did I get the center? And I'm reading it. I see they put down minus 5, 3. I feel good about that. Did I get the radius? They said it's 3. Now, the other thing they said is, did I get the correct points? I'm going to look at it. And what do they got? Minus 5, 0. I've got this one. Minus 5, 6. I've got that one. Minus 8, 3. I've got that one. And minus 2, 3. I've got that one. So what did we just do over there? We just did a review of what you've done in Math 100. All right. And of course, you repeated that in 119 as well. So I'm going to look at this parabola problem now. And let me write down for you. And, if I were looking at this thing and someone said, how would you do that Math 100? Well, probably the first thing I would do is just simply write the equation down. All right, we'll look at the picture. And before I do that, I want to just simply say, certainly I'm on autopilot, thinking back to what I did in Math 100. In Math 100, you just said, if it's factorable, factor it. Well, let's see if that's true. All right. So x and x we have true. 3 would be 3 and 1, right? It looks like plus 3 minus 1, but it looks like, I don't know if it's correct. That's giving me x squared. That looks pretty good. Then you get, 3 minus 1 is 2x. That looks good. You get minus 3. That's not bad. Now, another thing you've done in 119, you might have written it in more of a standard way. And by that, what you do is like a translation problem. And you might have completed the squares. Let me go through that with you. Now, I hope you realize to complete the square on 2, you would take half of that. That would be 1, and you'd add 1 to it. But that's not the same problem, is it? But you have to do -4 now. What is it going to be equal to? Y equals. And even some Math 100 teachers teach it this way. It kind of varies. And that's a standard translation problem now. You know, what is it? It's really the parent curve would be the parabola, whose the parent parabola is a vertex 0, 0, and it's shifted 1 unit to the left and 4 units down. That's pretty simple. All right. Now, what would you have done in Math 100? You would have definitely identified the vertex, and we'll talk about the formula for that later. You would have done the x-intercepts if they were easy. You would have done the y-intercept. The Math 100, they were always easy. You would have done an axis symmetry. And let's identify these things for you. All right, one at a time. Looking at my picture, it appears to be 1, 0. That's an x-intercept. We're doing x-intercepts now. What's this thing looking on picture? To me, it looks like -3, 0. All right, what's this thing over here? It's the y-intercept. What's the y-intercept? Well, looking at it, 0, -3. What's the vertex looking at this thing over here? And again, I'm looking. I'm not saying I'm doing any work, except for looking. It looks like to me -1, -4. All right. What's the other thing I'm looking for? That axis symmetry. I'm seeing whoever did the picture for me was quite kind. They drew it in for me. And what's the axis symmetry? It looks like x equals -1. Well, stuff you did prior. All right, let's take a look. And I want to point out, looking at this thing over here, I want to see if this is true. All right, so let's go through one at a time. And I'm looking at this. And I'm looking at this. The y-intercept, I want to tell you what we're doing over here. To get a y-intercept, all you have to do is set x to be 0. And if you did that, you get -3. That looks good. To get an x-intercept, what do? You set y to be 0. And when would y become 0? When x is 1. Well, I see that. And when x is -3. And I'm seeing that over there. All right. Now, someone says, how'd you do the vertex in Math 100? Well, I'm hoping your teachers explain to you that it's a dead center between these things over here. And what's the center between -3 and 1? We'll add those two numbers together. We'll derive the formula later. That would be -2, and divide by 2 would be -1. So the dead center would be -1. Where's the vertex? It's on the center line. What's the center line? Well, x has to be -1. What do? Take the -1, plug it in here. What would you get? -2. This would be 2. Well, -2 times 2 is -4. Relatively simple computation. Other teachers in Math 100, what they did was they wrote into the standard translated form, which you discussed in Math 119 as well. If that's working for you, good for you. It's working for you. By the way, standard form is nice because you can read the vertex immediately from it. This becomes -1 right there, -4 right there. Okay? All right, let's go to the next page. We're done with that. And we're going to talk about some formulas you were given in Math 100. And again, we're just going through what you learned in Math 100. Let me just blow this up a little tiny bit. And we're going to talk about, some of the formulas you got in Math 100. All right. So some of these, they gave these formulas to me, but they really never derived the formula. So I'm going to write this over here for you. So, the equations you were given in Math 100, are basically y equals ax squared plus bx plus c. With the understanding that a, b, and c are constants, but a can't be equal to 0. Right? Really important. So what your teachers told you in Math 100, they told you it was pretty easy to get the vertex from this statement over here. And they gave you a formula for it. And they gave you this formula over here. They said minus b over twice a would be the x coordinate. And the y coordinate would be f of minus b over twice a. And some students just accepted it. All right. Now, this understand that y is actually a function of x. What I want to do is I want to go through it. And when I go through it, you might say to yourself, I've seen that before, or I haven't seen it before. It's nice if you could understand where it's coming from. And again, we're reviewing Math 100. We'll get to the more advanced material later. But here's the deal. And I'm gonna write down the x-intercepts, by the way. And what's an x-intercept? All you have to do is set y equal to 0. So if you did that, what would you get? You get 0 equals ax squared plus bx plus c. Well, you know what? I don't know what a, b, and c, I just don't know what a, b, and c is. So what I have to do? Quadratic formula. So what do I get? X is, I'll write this down for you. Kind of complicated, right? Twice a, let's see, minus b plus or minus, that's the nightmare over here, b squared minus 4ac. Well, I'm going to write down both x-intercepts. And the first one is going to be minus b minus the square root b squared minus 4ac over twice a, comma 0. And the next one is going to be minus b plus b squared minus 4ac over twice a. Yeah, I know this is tedious. All right, now if you remember what we said about this in the picture, you know, I got something, a picture looks like this over here. And just something, let's say the x-intercepts are here. What do I know? I know the vertex is the dead center. So then the question becomes is, what is the center? What's the center between us? Well, what do? You add them together. And if you add those two things together, what would you get? And I'm talking about the center now. That's what I'm talking about. I'm talking about this guy over here. I'm talking about dead center of those x-intercepts. Well, if you added those together and divide by 2, this is what's known as a midpoint. Well, let's see if we can do that. Looks tough, right? Add them together, divide by 2. Well, I'm going to write this down now. Well, the y-coordinates are really easy to do. What do you get? 0 plus 0. The x-coordinates are more complicated. I want to point out what we're doing over here. We're taking this and we're adding this. We're just adding those things together. We're going to divide by 2. And what would that give you? Well, I'm going to write that down for you. I know I get a denominator of 2a, same denominator, right? And if you add the top together, what would you get? You get minus 2b for certain if you add those together. But what's nice about this, and I want to emphasize over here, if I add these together, this is minus and this is plus, and that would disappear. And that's good news for me. Let's keep going. We're looking for this midpoint between the x-intercepts. Now, this is true whether they're real or complex. And let's write this down now. Well, the second coordinate 0, that's easy. And what's this guy over here? Well, it's minus b over twice a. That's what this point is. So what's the vertex going to be? It's got to be on that line. So it's going to be minus b over 2a f of minus b over 2a. All right, point out where that is. It's right up here, and we derive that formula for you. So that's like basic math 100 question. All right, so what are we going to do now? We're going to talk about the more advanced material. All right, so we just did a little review of what you did in Math 100. Now we're going to do the more advanced material. And it's not easy. All right, we're not easy. So let's talk about this now. So it says, we're going to have a more formal approach now. Okay. For example, we can describe a parabola as a collection of points. And this is what's known as a locus. It's the loci problem, right? It's got to satisfy these conditions over here. And this is where people get really tongue-tied with this. And I understand that, all right? So it says these points. Now, what is it saying? Points on the parabola. There's points on the parabola. And what does it say? It's equidistant from a fixed line. That's called a diacritics. It's a fixed line. And fixed point, a focus. Wow, let's take a look at that. These points, x, y, in the parabola are equidistant from a fixed line, we'll get to pictures later, and a fixed point, a focus. The focus is not on the directrix. The midpoint between the directrix and the focus is the vertex. Look at a picture later, okay? The line passing through the focus and the vertex is called the axis of symmetry. We've seen that before. The standard form, well, I guess sort of like the circle, of the equation of the parabola with the vertex HK is given as follows. We're not asking to memorize. Horizontal directrix, vertical directrix. We're not even at the picture yet, but they give these things over here. Now, granted, when I say they give these things, our goal is to get these things. All right, let's go to the next page. And I'm going to talk about what they just said to me. And this gets tough. There's no doubt about it. And we'll go to a real simple derivation. But right now, I want to point out, looking at the picture, and by the way, I really don't want to talk so much about the numbers on it, but I have to, all right? I really have to talk about the numbers on it. So let me point out, I'm kind of looking at it, and I'm going to say that this point over here should be clear as day what that point is. And what is that point? That's the vertex. I'm going to put that down for you. Write vertex over here. And what is that point? Well, looking at it, it's the point is going to be, let's see, 1 minus 3, right? Okay, I'm going to talk about another point now. I'm going to talk about this point here. This point is called the focus. What is the focus? Well, looking at it, the focus is 1, comma, minus 1. All right. I want to put something else down over here. I want to talk about this line over here. Whoops, sorry about that. Let me just make sure you know what I'm talking about. That line's called a directrix. And what is that line? Y equals minus 5. Okay. The other thing I want to put down, well, not terribly important, is the axis of symmetry. And what did they say about the axis of symmetry? They said it's a line that goes through the focus and the vertex. And by the way, that line is perpendicular to the directrix. So the axis of symmetry is x equals 1. All right, now someone says, what are those other points over there? Just a visual aid. I'm going to talk through it one step at a time. All right, one step at a time. And I want to look at distances over here. I want to look at this distance here and this distance here. Now, in the description, what they said is, it's got to be the same distance. They said the distance from a point on the parabola to the focus should be identical to the distance from the point on the parabola to the directrix. Well, what's this distance over here? Looking at it, this distance over here is 2 units. What's this distance over here? It's also 2 units. We call that the number p. All right, let me repeat this over here. The distance here and the distance here has to be the same. And looking at it, it looks like 2. All right. I'm not going to really tell you what the other distances are, by the way, but I want to emphasize we draw these pictures so you can look at them and study them. What I'm going to claim is the distance from the foci to this point in the parabola is going to be identical to the distance from the point in the parabola to the directrix. And the distance here is going to be identical to the distance over here. So forth and so on. For example, if I did this, and then this, I would say they're the same distance over there. Now, someone could say, that would take me all day to do that. Well, I want to take a simple example, a real simple example, all right? And I'm going to push this over here. I'm going to do a real simple example now. And what we'd like to do is, we'd like to take a real simple example, and the example we're going to pick is going to be the parabola, all right? Now, I say the parabola where the vertex is at the origin 0, 0. Now, later on, we're going to just go back to 119 and we're going to move that around. But right now, I'm going to put the focus down right here. And I'm going to say the focus is p units from the vertex. So what would that be? 0, comma, p. Now, where would the directrix be? It would have to go through here, by the way. All right. So what's a directrix? Y equals minus p. Now, what I'm going to pick is a point on the, oh, by the way, the reason I say that, maybe you didn't follow that, it's got to be p units from the vertex. Remember, the defining feature is equal distance. What I'm going to do now is pick a point on the parabola, and I'm going to call it xy. Now, what I know about this, and again, I'm not saying I'm drawing a great picture over here. I know the distance between this thing over there, well, you know, it's a pretty bad looking parabola. You know what I'm going to do? I want to draw a better parabola for you. This is no good. And I'm going to see if I can do a better parabola for you. Push this up. Let me go back over that again with you. And this is going to be a parabola. Let me just see if I can do a good job here. It's always tough for me, by the way, I'll be honest with you. And I'm going to go for a blue line here. Directrix is y equals minus p. This focus here is going to be 0p. This point over here is the vertex. The vertex is 0, 0. Let me see if I can get a point that's sort of equidistant over here. Let me put that in for you. Let me draw my parabola for you. Yeah, not a very good job drawing a parabola, by the way. All right. So I'm going to just talk about points now. All right. Whoops, I made a mistake in my notation over here. So I get this point, but I don't have this point over here. So what is that point? Well, the only thing I really know about it is I know that the y coordinate has to be minus p. What's the x coordinate though? I point this out to you. We're dropping a line. It's got to be x. Put that over here for you. Now, what do I know? I know this distance, according to definition, is identical to this distance. If that's true, I just use the distance formula to derive the formula. Let's write this down. So the distance here, I'll call it D1, I'll call this D2. Let's write down D1 first. What's it going to be? Well, let's write this down. It's going to be x minus 0 squared plus y minus p squared. Don't be alarmed. What's D2? Well, I'm going to write down for you. It's going to be x minus x squared plus y minus a minus p, which is y plus p squared. Well, let's keep moving forward. And this guy over here looks pretty simple to do. You would get x squared. It was going to be a tough one, right? Plus y squared minus 2py plus p squared. What's this guy going to be? Well, it's going to be y squared plus 2py plus p squared. All right, let me point out what I mean by that. This becomes 0. That's an easy expansion. What do I know, though? I know that D1 is identical to D2 by the defining feature of parabola. So what does that mean? It means that this guy here has got to be the same as this guy over here. Let's write that down for you. So that means x squared plus y squared minus 2py plus p squared is equal to, let's write this down, y squared plus 2py plus, by the way, that's a p squared. Well, I'm going to subtract p squared from both sides. I'm glad that disappeared. I'm going to subtract y squared from both sides. I'm glad that disappeared. And what would you end up with in the end? Something fairly simple. You end up with x squared equals 4py. This is important. All right. What we're going to do, though, is move the vertex to a point h, k. If you did that, it's a standard translation problem. And what does one become? Fairly simple. X minus h squared equals 4py minus k. Okay, let me go through this a little bit at a time. We just derived the equation of a parabola whose vertex is hk. By the way, this is a parabola that opens up or possibly opens down. It opens up if p is positive. We'll go through examples. It opens down if p is negative. There comes the problem. In Math 100, you just did those two. Now we have two more to worry about. And the other two we have to worry about are the ones that open to the left and open to the right. Well, I gotta be honest with you, if I can do this one over here, what I'm gonna do is just replace, x and y. Let me see if I can do that. We'll look at the formulas later, okay? We'll see if we can do that. Opens right if p is greater than 0. Opens left if p is less than 0. By the way, I'm not asking you to memorize stuff. We'll go through examples. The key thing over here, though, before you do any problem, my suggestion is try to visualize what you're doing and find out which one it is. Is it this guy here? That means just go left or right. Or is it this one over here, up or down? All right. Let me go back to the notes. We just derived the equation of the parabola. And I want to go back to the other page. All right. And I want to emphasize what we just did over here. We just derived this formula here. We will certainly go through examples. And from that formula, we derived this one over here. All right, clearly written in your notes. All right, thank you. And then I'm going to say we'll go to examples. As we go to examples, we're hoping this makes more sense to you. But again, it's not easy. I know it's not easy. All right, we'll go to examples soon.